All right, welcome everyone. In 1 minute, we will begin Hacky Hour, NVIDIA Jetson JetPack 4.6, support with alwaysAI edgeIQ. So grab your favorite snack and we'll be starting shortly. All right, let's get started. Hi, everyone. My name is Lizzie Alves. I'm in the marketing department here at alwaysAI, and I want to thank you all for joining us today for Hacky Hour. If you're joining us for the first time, Hacky Hour is a workshop designed for our community to share new product releases, do code demos, and have engaging exercises in an interactive format. Feel free to use the chat window throughout the presentation to ask questions, and we'll answer them as promptly as we can. If you haven't done so already, please make sure that you visit alwaysAI.co and sign up for a free account to start your computer vision journey today. Today, we will be covering the new hardware and software features of NVIDIA's Jetpack 4.6 and demonstrate how to use alwaysAI's edgeIQ software with NVIDIA's new versions of CUDA and Tensor Rt. Afterwards, we'll host an exciting giveaway and we'll ask a question, and whoever answers it accurately and the fastest in the chat will win a free NVIDIA Jetson Nano. Now I'm going to hand it over to alwaysAI's co-founder and CTO, Steve Griset, and he's going to kick things off.
All right, well, thank you, Lizzie, for that. Before we get started, I wanted to introduce Olaf, a new member of our team who will be working as a developer advocate. You'll find him out on Discord and other places, helping you work through issues you might have or show you exciting new features. And I'm sure he's going to be stepping up and doing one of these real soon. So Olaf, why don't you say hi to the community for us?
Hi, everyone. Like Steve said, pleasure to be here. My name is Olaf. I am a software engineer and a developer advocate here at alwaysAI. And you can catch me on Discord if you have any questions. I'll be happy to help. Thank you.
All right. So let's go through quickly the agenda. We haven't really done an update on what's been going on with edgeIQ. So we'll go through the last two releases and what feature sets we have in that. Then we'll go through and do a little bit of an overview of Jetpack 4.6 from NVIDIA and some of the neat features they have on that. Then we'll just start to show how the two products work together. We'll do a demo on CUDA and then Tensor Rt, and then we'll move to a NVIDIA DLA, which is their deep learning accelerator, which augments some of the processing to the GPU. So that's the busy agenda we have today. So let's go ahead and get it started. So we've done two updates since we last talked to you with edgeIQ and one to the CLI. So anyway, the CLI, the edgeIQ update, well, the first one was 1.7, and if you think about GPS, right, and you can do geofencing and so forth, in computer vision, you really need to take a look at zones. So what am I seeing? My camera seeing in this zone, another camera, another zone, and so forth. And you need to keep all that together. So we've created some zoning capabilities into the product. So one, a tool to create those zones, and then a list of zones and zone classes that allow you to generate the analytics and see what's going on each one of those individual zones and so forth. Very, very important, and a lot of our customers are using it. We've also added barcode and QR code detection capabilities and decoding. And what's kind of unique about this solution is we stayed with, we are a machine learning computer vision company. And so we're using a technique called super resolution. So once we detect a barcode or QR code, we then will go ahead and use super resolution to update that system. Next, again, keeping with the theme here, we've added another Jetson device into our support, and that's the Jetson Xavier AGX, which is the most powerful member of the Jetson family, and able to do a lot of stream processing and so forth for an edge device. The last update we did, and we updated our open source middleware, and so now we're using OpenCV 454. So if you have, below, if you look at the bottom link there in the slide off red, those are the URLs to the different function zones and so forth on there. So again, presentation will be available after this, so you can go ahead and click on those and find out more information if you're interested in them. Next update, or next edgeIQ update, or next slide. So what today is all about. So we've just released edgeIQ 1.8. And that's your Jetpack 4.6 support for edgeIQ. So if you're still running 4.4.1, unfortunately, you need to stay back on 1.7. But if you do put in that 4.6 base, then you need to get the most current 1.8. We've also updated the CLI, and I think we updated it again. So, but anyway, while I was building this Hacky Hour, we've gone to CLI 1.4.3, and what was requested, this is really a response to some of our community and customer responses. So people working with analytics, one of the issues they had was it was really only available on the edge device, and they wanted to work on their host system, their workstation, and develop and test those functions without deploying. So we've added a certificate system to the CLI so that you can use those on your host system. We also had another request. So if you run alwaysAI app install, you will be bringing over, you'll be looking for updates for your Docker image. You'll be looking, rebuilding your virtual environment and go through all this stuff. But what was coming through on the community saying, I don't want to touch my environment. I just want to update the application code. So we've added an alwaysAI app install space -- source. And so what that will do is only update the application code. You're not going to get all the other pieces and so forth that go into the system. So nice feature there. And of course, CLI 1.4.3 will check for Jetpack 4.6. So anyway, and what I will say is if you're still running 1.7, you're still on 4.4.1, don't worry about it. That's a warning. You can still go ahead and function with the CLI. So just ignore the warning that you're on it. So let's move on to the next thing. So let's talk a little bit about what NVIDIA did with Jetpack 4.6. So some of the new features they added. So if you look at the class of systems they have on Jetson systems, they have a Nano, they have a TX2, and then they have their Xavier NX and AGX. So what they did was get a new mode that they enabled through software of a 20-watt mode on your Xavier NX. And why that's important is really performance is based upon how much wattage you're putting in to a certain extent. So what this did was improve the performance of the Xavier NX, allowing to run at a higher wattage mode. I think one of the more important ones that they've done is before, when you're updating the components of a Jetpack, you had to reinstall, like you have to do from 4.1.1 to go to 4.6. So you have to reflash that device. They now have over-the-air updates that are coming in. Now, unfortunately, that will help us with going to 4.6.1 and maybe 4.7 or whatever they release going forward on the 4.x packages. But they at least have that in place. So when they release 4.6.1, you'll be able to update in place over the air without having to reflash the device. This one's exciting for me. They've added support for SSD drives. So now, instead of just having their internal memory on their system as a module, they now also have an SD cards. They now have SSD drives that you can add, which really starts to make that Jetson look more like a workstation and so forth, or a production level device, and expand what you can store and how fast those systems can come out of storage. So, and it will boot off those SSD drives. So that's a very nice function. Camera support. So there's always been standard. So the AB is asking, is this USB boot or M2? It's an M2 SSD, and I think you'll have to look at your board manufacturer to find out the key type that you're going to support. On the Jetson, I think it's an M-type key on it. Yes, they do support USB support boot drive too on that. So the answer is yes to that too. So all those things are now supported by the system. USB drives a little bit. You need to go to get the directions. It takes a little bit more effort to do. But it's pretty well documented and so forth. And if not, I think there's a Jetson Hacks is out there. Thank you, AB's ahead of me. It's the place to go. And he's absolutely right on that. So you can go take a look at that, and it'll show you how to do the operating system. It's pretty straightforward on the Jetson drive using the NVMe SSD drive. So again, so now let's go down to cameras. Before, those of us who used, so the IMX219 is your standard Pi camera. The IMX219 is just the sensor type in the camera. But for a while, high definition cameras have come into on the what they call the CSI interface for the cameras. And you could get IMX47, which is that advanced one. But it was very hard. You had to do kernel recompiling, everything else like that. So they've added support, and then right below it, they've added a tool so you can configure all those, the last two features I've shown you into your system. You can even reset your, depending on your carrier board vendor, you can reset the GPIO pins and other types of stuff to it with this new tool that they have on. Of course, in the Jetpack right now, they've added the standard TensorRT, CUDA, and CUDNN support to this. That's a good question, AB. I always saw it as the replacement to the wiring of the Pi on reconfiguring the pins as something that has to do with more your carrier board type. So if you go off and use a Seed Studio, one of our partners carrier boards, let's say the A205 might have a different pin out and so forth. It doesn't, but there can be, I think it's EX1 has different pin outs and so forth to it. So it allows you to rewire differently the pin outs, if that's the question, from what the Pi is. So I guess that's the answer. I'm not sure if I got, answered it succinctly, but yes, if you have a carrier board, you can rewire the pins to be different from what the Pi is, and again, that's really, I think, more dependent on your carrier board and so forth, that they would change the pins, but you could change your pins too. So,
Steve, it looks like we have another question. Is slot PCI Express?
I'd have to take a look at that. It can be. Again, I think it's the carrier board. So AB's got me on that one. He says, yes, it is. So I'm going to trust that AB in his lab has played with this a little bit more. So, so the answer is yes. Yes. Okay. So he's saying the interface and it is a PCIe compliant system. All right. Any other questions as we move through on the Jetpack 4.6? Because I know it's pretty exciting to boot off a solid state disk drive. So cool. So we can go ahead to the next slide. All right. Let's talk a little bit about hardware. Feels like we have been talking a little bit about hardware, but let's talk a little bit more about hardware. So the hardware support and that you have now in this Jetpack is for the whole series in the Jetson Nano line. And the Jetson Nano is really their entry board. The 2 gig will be similar or maybe even less than the Raspberry Pi. And the 4 gig is probably going to be a little bit more given chip shortages and so forth, but they'll be close to a Pi is what I want to say right now. And it has a 128 core GPU with it, and 2 to 4 gigs of memory that you have working. It's an excellent board to learn about NVIDIA's software stack and to prototype. I would say that for production, it has really a small window to be used in production, but it's an excellent board to prototype. And just kind of stepping back, if you're really serious about being in computer vision and wanting to do industrial grade or real-time grade applications, then Jetson's really one of the platforms to be on. Raspberry Pi, it's a little bit tougher to get there with those, to get them into production. So that's why we're spending our time on Jetpack, because this is really your industrial-based computer or your production-based platform for computer vision applications. So with that said, NVIDIA recognized that too, and so they introduced this TX2 NX support. And so what that will do is give you a little bit more oomph as a system. It is 4 gigs, but it's running so the Nano runs a Maxwell generation of GPUs. That's a very early generation for NVIDIA on GPUs, and the TX2 is running a Pascal version of it. So then it's got a 256 core, so a little bit more oomph, same memory space and so forth. So for your lower end production, the TX2 NX is a very nice device. It's actually costs pretty close to Nano. But now for true production, your Xavier NX, and we've talked about it, is really that I see as the entry level. And today we support the Xavier NX 8 gigs, and all the demos we're going to do today are going to be on that processor base, and it will be running at 20 watts off an SSD drive on it. And so the developer kit has a slot for you to put that SSD drive in. At the highest end is the Xavier AGX. It has more processor cores and so forth, and it runs 16 to 32 gigs now. And all Xaviers run on what they call the Volta family of GPUs. But the difference is the NX is a 384 core system, and the other, the AGX is a 512 core system. So a little bit bigger one. The other thing the Volta brings to you is something called Tensor Cores. Tensor Cores are a way to speed up some of the mathematical operations and so forth. So if you try to get to a precision of like int8 and things like that on these GPUs, those are going to give you the horsepower to run at a precision level int8. So that's the overview on hardware. Why don't we jump to the next slide? All right, so this is my take. So if you're going to jump off from your Raspberry Pis and get into and other devices and get into, hey, I want to learn about NVIDIA devices and so forth, this is really my minimal recommendation. You can choose any of the developer, just Nano developer kits. Just depends on what speed you want to run things at, how many CSI cameras, and so forth. So you can either choose a 2 gig all the way up to the B01. The B01 is what they call the system on a modules is based on. So if you buy a Nano SOM, which we're giving away today, that's based on the B01 platform. And then, if you're using SD cards, what I found is the easiest way is just to get to 64 gigs. So pretty close in price and so forth, but use that as your place to prototype and so forth. That's it on that one. So there's my recommendations. I'm sure people have others, but that's it. So, all right. So, let's talk about what alwaysAI brings to the table over NVIDIA. So the way really development is done out there, and you do it through your Docker containers and Docker images and so forth. That's the way NVIDIA recommends. That's the way we have always done things. So it's pretty common to run a container-based system out there. So NVIDIA provides a generic container. And so what that container has in it is, in the image that's in that container is Python 3.6. Got all the core software we talked about. And then it has an open source middleware of OpenCV, and it's version 4.5.1. Now, alwaysAI, we decided we want to enhance this and add to it and make developers' lives easier out there. So with our containerized software, what we're doing is, the Pi moved and other edge devices moved. So we decided that it was really time for us to move to Python 3.7. So we have Python, and we've had that through even when we were supporting the 4.4.1 container. So we were a Python 3.7 base. And the reason I wanted to point that one out is that means some of the dependencies, as you add third-party packages, make sure when you're targeting the versions of those packages, you're targeting for Python 3.7, not 3.6. The other enhancement we have is edgeIQ, our computer vision framework is running in that container. And so we, of course, believe that's a big value add. The core software is going to be the same. But then we get down to open source. So we realize that developers in computer vision love OpenCV. And so we have the latest, most stable version that we see out there right now. And that's OpenCV 4.5.4. And here's the take that's a little bit different, is we enabled it to work with CUDA backend. So there's a whole series of APIs within OpenCV that can exploit CUDA, which means, we'll explain what CUDA is, but basically allows you to access the GPU and use the GPU in your OpenCV effort. So that's in our container as part of the open source. I'm a great lover of dlib, especially if you're doing facial recognition applications and so forth. So AB is also, I think AB did a Hacky Hour around that. But that's in there, and that has been compiled to take advantage also of the CUDA backend. Now, we've talked a lot about PyCUDA, or we talked a lot about CUDA, but there's also a standard set of APIs allow you to do matrix manipulations and things like that on your own within your system. And we also have PyCUDA pre-installed. So that's the Python wrapper over the C APIs for Python. So, and that's the pretty latest version. There's a version newer than that in the PyCUDA, but it's simply dropping support for Python 2.7. So do you need CUDA directly? The answer is it depends. For using edgeIQ, no, but for OpenCV, there's a series of APIs that you can look up. So for edgeIQ, I'm going to show you how to use that system on it, but you don't, we tap the backends for you. So, but if you're using OpenCV and things like that, there are, and what we're giving developers is you can address CUDA if you want to, either through OpenCV or PyCUDA or dlib. It's actually automatic on dlib, by the way. So. All right, and by the way, on the OpenCV side, we did have CUDA and contours earlier, Hacky Hour, and go back and take a look at that, and it talks a lot about how to use OpenCV's CUDA. And Chloe, thank you very much for putting that out there for us. So that's the other one, and that goes into a lot of detail on how to use that with OpenCV in an alwaysAI environment. All right, next slide, please. Hey, so let's talk about CUDA a little bit. So what is this thing we've been talking about? So NVIDIA not only developed a very interesting hardware in its GPU, but it also decided to go away from something called OpenCL and develop out its own software, and it's called Compute Unified Device Architecture. And what this does is allows you to, from programs executing on the CPU, to call functions in the GPU and load memory and so forth. So it's making a very tight cooperation between the GPU and the CPU. So what that allows you to do is get that graphics interface originally in C very easily, and then obviously with PyCUDA in Python that you can do that. So what it does is really open up that GPU and its usage. We like to say, and I think maybe the reason AB brought up CUDA to begin with, you have to know CUDA to do all these things. And the reason is CUDA to us is like using assembly language in some way. You have to know a lot about the GPU architecture to do it, things like streams and sinks and so forth. We take care of that. We do the inferencing low, it doesn't put a lot of pressure. You just have to designate that you want to use CUDA and we'll see that in alwaysAI. So that's not an issue. But if you're going out, and the reason, even using OpenCV, you do have to know a little bit about the CUDA architecture. Again, not to pump up my old Hacky Hour, but we talk a lot about that in the Hacky Hour and so forth. And there's a lot of books in the industry on how to use CUDA and PyCUDA out there to get to it. But anyway, that's the important secret sauce that NVIDIA has. CUDA is important in one way. Most video games you're going to play today is probably going through CUDA as an architecture. So anyway, CUDA also has OpenCL calls that you can make too in its API. So I just wanted to add that. All right, too much on CUDA, but let's go to the next slide. And so, okay, all right, let's see how you can use CUDA and edgeIQ. And let's go through that right now. So I'm going to go share my screen, and everyone, keep your fingers crossed everything works, because this is a demo. And let me go ahead and share. And so Lizzie, I'm going to ask you, can you see my screen at this point in time and all the fun stuff on that?
Yes, I can.
All right. So the first thing, before we get started into the application, I did want to show and how do you get to that new tool? So right now I've SSH'd into my Xavier system right now. And what I'm going to do is type in this command, and it went very fast, but it's really, you go to sudo, and that's how you get to the jetsonio.py command. Let me go ahead and share that in chat. Hold on one second. So let me go over to chat, and I will go ahead and I'm going to type it in the, let me do my, to everyone, and I'll put that command in there for you. So hold on one second. So if you execute that command at the command line, and then I'm going to, sorry guys. Sometimes I think that Zoom likes to overshare. And then anyway, so this is it. And let me go ahead and go full screen onto it. So this is the tool, and what this tool will allow you, and what AB was asking, you can reconfigure the Jetson 40-pin header. Yes, you can. And that interface is in there, and you can go through and set your pins as you need to do. You can either do it manually and so forth on it. What's important too is setting up those CSI cameras. And so if we go in there, you can configure them, and you can set it up for either the NVIDIA Xavier kit has two CSIs, so you can set it up either to run just strictly IMX, or you can set it up to do dual IMX 477s, or you can choose the camera like I did to set up. I like using both to test the IMX 477, which we're going to use today, and the IMX 219 on the B and A slots. I think on the board it's going to say 0 and 1 when you look at that, but A is the 0 slot and B is the 1 slot. All right, so, and then last, as we go back, and then if you were to save this off and so forth, it will rebuild and reset the kernel appropriately to handle the system. And then you can go in, and if you have the E slot like we have in there, you can reconfigure that pin depending on what your guides are in there. If you get some weird device that has different pin settings and so forth.
We have another question for you.
Sure.
AB is asking, what advantages does this bring? Any optimizations for camera selection?
So, I guess I need to know the nuance of that question. Sorry on it. So what it does for me is it allows me to set up the cameras and recompile the kernel through their scripting as opposed to me having to do it. So for the IMX drivers, particularly the 477 and so forth. So I don't get just stuck with the default and then have to recompile the kernel myself. I don't know if that was the spirit of the question. So I know, AB, does that get to it? It doesn't feel like it did.
He added, it doesn't auto detect.
No, it does not auto detect. So what he's saying now, he's gonna say, hey man, my Pi auto detects, and he's absolutely right. It does not auto detect. That is not, the Xavier is behind the Pi on that. Or I should say the Jetson product line.
That seems to have answered the question. Thanks so much, Steve.
Yeah, so that's a good point. So if you're used to working with Pi's auto detect and so forth. So let's go ahead. So we saw the tools and so forth, and then I'll just show you, once I've reconfigured, the other little command I like to always put in here is to go through and check it. And so what I'm going to do here is I just simply go through my message queue and I grip, and I want to see whether the cameras have bound and are found. And this also is a good way of checking whether I've connected the cameras correctly or not. So if you go through and you see this, basically I go through and I'm parsing through and I can see that my IMX camera is set up on port A for 477 and port B, and they have bound correctly. So the board has found the CSI camera and they have communicated back and forth. So that's just a thing that I do. You don't have to do it. But especially if you're going to start to play around with that configuration tool, you might want to see what's bound where. So that's just a little thing I wanted to show you. Let's go ahead and let's get started. So what we're going to do today is we're going to do the CUDA, get to CUDA, like I said, and we're going to use it just using standard off-the-shelf applications, our starter apps that you can get through the CLI. So we're going to spend most of our time on the CLI today. But I did want to show you, as we come up here, that if you go to alwaysAI, right, we have a whole GitHub with the reference apps are there. But I put together a Jetpack, also 4.6 Hacky Hour, and there's stuff in the README. But basically, the CSI camera application can be that base application if you want to go and build this out later. And then we have the models and the tool that I'll show you. So it's all there. You can download, you can relax and watch right now and listen. And then later on, you can go back and replay, and you'll have the source of everything we did today and so forth. So let me go back to my piece. So what I'm going to do is just basically start to run our CLI, and there's all kinds, if you go to the dashboard and so forth, it tells you how to set up the CLI. I'm going to assume all that's been done, or you've gotten through that. So now we're going to get ready to build using alwaysAI's command line interface tool. And so to get any project or any application started, the first thing you need to do is configure it. And then if you want to retarget a device, you can use configuration to do that too. So let's go ahead and just create a new project called, we're going to call it Hacky Hour, and start. Okay, so what I'm going to do is if I wanted to clone from a repo, I can do that. If I want to just go to one of our default starter apps, I can do that. Or if I have a project already set up, some software I've already done, I just say, give me an empty app file, which is our core application file, and then it won't overwrite anything and so forth. So let's go in and we'll do object detection. As our one, you can choose different ones, but today we're focused strictly on object detection. It's the easiest to demo and the most used out there. Okay, we're going to go to a remote device. So we're configuring what device is going to be our target from our development system. And so what I'm going to do is, hey, look at that. So I have, I don't want that one. I want my Xavier. So that almost was a big mistake to start out. So where is my Xavier? I have a special one name. There it is, Xavier Jet. I almost chose my Nano. That would have been interesting. Now, while that's copying over, so what this does is it sets up my Docker system, sets up where my target drive is as we go through. A lot of you have seen this before, but I did want to bring this back up. So did I do it right? Okay, I always worry. No, I did it in the wrong directory. Okay, so let me get rid of this. Sorry, good people. I want to make sure I do it in my right directory. I just simply wiped out some of my development. So let's go back through that. That was a mistake. Pay attention to this one. And call it Hacky again. From my starter app to my object detector. This happened in trials yesterday. I went ahead and was in the wrong directory. Make sure you're in the right directory when you run this. Don't be like me. Okay, so everything's going to be the same here. And there's my Xavier Jet. So again, it's going to rebuild and so forth. But what I did want to show you is this is running on an SSD drive. So what I'm going to do is show you, if you see the file system here, so it's a 229 gig drive and it's all booting off that system. So there I wanted to show you what we're using on the Xavier and taking advantage of Jetpack. Okay. So anyway, what we've done is now we've created the application, we've created the configuration files, and we've made sure our Docker system is ready to receive all that system and container. So what I'm going to do now is just go to my IDE and we'll take a look at it. So this is a standard outline where here's the object detection where you load the model, and then here is the where you load the engine, and the engine is how is it going to execute, and DNN is standard CPU inferencing engine that we have, and then the rest of this is an FPS tool we have, frames per second tool that's in there, and then this says I want to use my webcam, and then the output's going to our streamer. The streamer is used usually when you're debugging and developing, so forth, so you want to see what's going on into the system. And then really the work starts here. You start your FPS, and then you're going to loop through and do your detection. So first of all, read in the video stream. And then you're going to go ahead and run an object detection and on that frame, and it's going to give you back a results object. Then what we have is another API that will parse that results object and so forth. It's all in our API guide and so forth, and we'll get into some details. Now, we just made a big fuss of setting up CSI camp. So the first thing, actually, let me go back up to here. I want to use a standard COCO model, the MobileNet SSD model, which comes from our open source catalog called the model catalog. It is just running what they call the Pascal VOC set. So I think it's a series of about 20 objects it can do. I want to get over to Google's MobileNet SSD that has that's COCO, that's pretty standard for the based on the COCO data set, 91 things it can detect. And so I want to change that. So I'm going to show you how I'm going to do that within our model catalog. So I'm right here hopefully we can see this a little better. We're tight on space. I'm on the dashboard, but what I want to do right now is move from my dashboard to my model catalog. Go in and go to object detection. And then what I'm going to do is I'm going to search for COCO. Things are based on the COCO data set. And there's a lot based on the COCO data set, your YOLO models and so forth. It's way down there. So what I'm looking for is this guy right here. So this is the standard Google created, obviously, in 2018. And we can even see the month and day. And so this model is, like I said, pretty standard for devices and so forth. So I want to add this model to my project. So what I'm doing is copying it. I go over to my command line, and hopefully the right command line this time. And that's the wrong command line. There's the right one, where my project is. And I'm going to go ahead and just paste this in. And so what it's going to do is download the model and put it into my model cache. So now you see I have two models associated with my project. Another useful tool you can do is, and this is really the command. So there's a couple commands here I'll show you on here. So this is model show, so I can see what's connected with the project. But I can also do this. I can do a remove, right? And what this does is help keep my project a little bit neater. And I'm not going to use this model at all. So I'm just going to sit here and copy this and then remove it from the system, because it's not germane to what I want to do today. So bingo. So now I've eliminated that model. And so if I did the back and show, you can see now I only have one model associated with the project. Now, the next thing I need to do is add it to my application. So my application will look at that. So what I want to do now is go back to my model catalog, go ahead and copy this. And then I'm going to come into here. And bingo, there it is. And I just saved that off. So now I'm ready to load this new model from the alwaysAI catalog and get ready to go ahead and inference that system and deploy it and so forth. Now, the problem is I don't have a webcam. I have a CSI camera attached to my, and this is calling for the webcam API. So how do I change that? Well, there's always an API for that. Now, when dealing with Jetson CSI cameras, and let me go over to docs here on our thing and going to edgeIQ. When dealing with, and again, I'm going to come here in video streaming. When dealing with Jetson cameras, it's important to know that they have their own drivers. So you can't use DreamStreamer or something like that to get into it. What you need to do is use an API that's designed to tap that Jetson driver. We come down into our catalog here, or down into our API guide, excuse me. You're going to see, here we go. So we're going to need to set up a Jetson stream, and that will tell us, which camera to use. By default, it's looking at 0. What is the rotation? So how do I want to rotate that camera view? What's my display side? And then what's this weird thing called camera mode? So we go up here, we have another API with a bunch of information on it, but we want to either tap an IMX219 camera mode or an IMX 477. I'm going to run the 477 today. And so if we take a look at this tells us what the sensor is. This gives us the width and height. And then this says how many frames per second. And this will give you the mode, right, that the driver is looking for on it. So what we're going to do is we're actually going to run in this mode. So I'm going to run this at 60 frames per second today because I can, and in mode 1 on the IMX 477. So we're going to have to go change that code on the video streaming, and we're going to go, let me go ahead and do this. And this is, again, what we're trying to do is have me copy and paste today, because sometimes my typing skills aren't what they should be. So we're going to come in here and we're going to replace this line. All right, so we're going to go ahead and do a paste here. And we're going to drop it, and we're going to get a lint error. So that's interesting. And I think we're getting the lint error here because there's no parentheses. So we've gotten rid of that and so forth. So now what this is going to do now is use the Jetson video stream on our system. So we're all ready to go. And you're saying, but Steve, we haven't done CUDA yet. So yeah, we haven't done CUDA yet. And we're going to do that. I'm going to show you how to use the CUDA backend. But first, we're going to go ahead and process on the GPU to see how fast it works. Not CPU, excuse me, before we go to the GPU. Yeah.
Hey, Steve, there is a question here. Could you re-explain about the mode in the last digits in the model?
Yeah, the mode is simply telling the Jetson driver what to configure itself as. So that's what that mode is. And when I start the system, I'll show you the different modes that it can come up to. So the driver itself has modes, and the modes will to the driver determines that it's 1920. It doesn't do human readable. It determines it's 1920 by 1080 and 60 based upon the mode. Hopefully that makes a little sense. So it's just the mode of the NVIDIA driver.
Yep, that looks like it answered it. Thanks,
Okay.
Steve.
Okay. Yeah. So NVIDIA is always a fun thing. So let's go ahead now. We've saved off, and we're going to go ahead and we're going to go ahead and do an install. And the demos will pick up faster because this is the most altering of the code I'm going to do today. So what you see here right now is, and if you're doing this at home, it's going to go ahead and tell you what version. Right here, you can see what version it is. It auto detect the hardware you're on. And then the image comes through. And if you didn't have this Docker image, it would download it automatically for you. And you can see that is, and then we're going to install our model on there. And then we'll build our virtual environment as the system goes through. And then you have a requirements.txt that's in there. So if you want to add third-party libraries to your application, it will look at that requirements.txt and then build the dependencies. So we should be good to go. Hopefully everyone is knocked on Formica wood or whatever. And what we're going to do is simply load the start program, and then we should start to see some results. So there you go. What it does is show you, so you're going to run, and this is misleading. This is trying to use the OpenCL's GPU. It should say CPU. We'll have to work on it. But here's what happens. See, this is, the camera gets, see how it says mode 1 on there? So they answer the question. So the camera driver's coming back. Okay, you told me to go to mode 1. I go to mode 1. There's my width and height. And then basically, I'm going to be running around to 60. It's at 59.999, right? So it's up and running, and that's where all that configuration for the camera came in, and what we're doing in that API for you. We're telling it this is what you run, this is what we go. It will list a whole bunch of available modes as it's coming up too for the driver. It's very verbose as a driver. So let's go up to this and let's go see what's going on. So you're gonna see my chair and my wall and some books back there, but you'll see me. So it's live, right? Here we go, Steve. He's here. And what's interesting about this is running straight at 20 watts on the 6-bank GPUs of the Xavier, and the system is running, as you can see, roughly a little bit over 100 milliseconds on average on its inferencing time. So that's not bad on this one. For it just using the CPU core. And let me show you, there's a tool, and I tell you how to load it in the README of it. But there's a tool that people use to measure what's going on in your Xavier. It's called JTOP. And again, within the README of the GitHub, I tell you where to go and install this tool. This is one of my favorite tools. I don't think Lila likes it as much as I do. But she's enthusiastic for me. So what this shows me right now is my GPU cores are running, or my CPU cores are running and doing the inferencing. You can see some of the memory. The GPU is simply the video output that's being hit at this point in time. So you can go in, you can see this is what's going on with the CPU. This is what's going on in the GPU, and that's very much just kind of video processing and so forth. I can also reconfigure the system if I wanted to from this standpoint, and I can take a look at memory usage and so forth. It's obviously not swapping or anything like that, and just go back to it. So it's a really nice tool to have to see what's going on if you're developing. And again, the repo to install that tool and so forth. There's even some packages where you can set up within your own application that has, you can use their libraries to get information if you want to feed it back to your application. All right. Oh, yeah. And one of the reasons that's important is it also has temperature and GPUs run hot. So let's go ahead and stop this application, and we're going to try to move to CUDA. Not like that, but I did want to come back and show you that this ran about 8.6, 8.7 frames per second, the application from the stats we collected while it was running. So let's go ahead and say, well, gosh, I really want to use CUDA and the GPU. So let's see how hard that is. So it's fairly easy. Now, when you're going through the application, let me give you a kind of a helper here on it. So if you go to our API and our docs, right, where are you going to find the easiest way to find it? You can go look through object detection and read through it. And there's a lot of information on how to set up an object detector and how to run one. But really, if you want to figure out what backend to use on, and we call them engines and so forth, the really interesting thing is to go here to constants. And so we'll see that the only thing I really need to change to do this is the DNN command into our API. So to reset the engine. So what does that mean? So let's go look at it in code. So the only thing I have to do here is go like this. And this is going to now, so this was getting down to ABs. Do I have to know all my CUDA commands? Do I have to set up a whole CUDA system to do this and so forth? Answer is no. You just have to make that change in the API and then reinstall. That's also important. And I keep wanting to bring up okay, got it right that time. So we're going to go ahead and put the app install, and we're going to run this again. And it's going to go ahead and install the model again, do all the updates. I actually should have used our brand new command, which was, and I'll show that the source. This is one of the cases where the only thing I changed was the source, and I'm going through this. And I'll redo this and show you the new command. If I just did this, I wouldn't go through all the stuff I did before. So I'll show you that because I've only made a change to my application. So I should be using the new command. So we'll go ahead and do that, and then boom, as you see, it's pretty, and it's going to ignore all this other build Docker image and all that type of stuff. So that's a new command that makes it easier if you remember it to work with your source code if you're just making a source code change, which I just did. So anyway, so that's all done. Enough commentary there. We go into the start command, and then we're going to see what we get out of this. And I realize it's indoors and everything. It's not as exciting as outdoor to see, because you're only going to see me and some books. All right, so it looks all the same, but let's go up and let's take a look at our Xavier again. And again, through the IMX camera. Come on, baby, don't crash on me. There we go. It's me again, and you're going to say a big deal. But here's the big deal. Let's go to what the big deal is. Remember, we're up at 100 milliseconds. Now we're going at 16 milliseconds, roughly 16 to 17 milliseconds. And this is running really fast. So what does this mean to me? This means you can start to do real-time applications. So this is what your customers are going to ask for when they're out there. What's going on in real time? How are things going on? What's happening and so forth to that. And this is, remember, we have a very threaded system and we don't double process frames in our video drivers. So this is each new frame coming in to the system at FPS 60, it is processing. So keep in mind, our application on the last one was running 8 frames per second and an input speed of 60. So just, I want to make sure people get that. idea. So we'll go ahead and stop this because it's coming so that we can go see some. Gosh, I just want to press the wrong button all day long. So actually I should have let you see what's going on. So let me restart that app. I should have shown you what's going on. I'm sorry about that. It'll just take a second to restart. Second's over with, system. All right. So I did want to show you what's going on with the Jetson system. JPack on this. So that's that. So let's see. So let's see what happened. I think that, let me restart my JTalk. Kind of crashed on me there. So now you can see what's going on the system. So you can start to see, if you remember before, you see the speed and everything, what's going on? Well, the system, you can see the memory and the EMC is all up, and the GPUs. Remember before how that GPU was just doing some video output stuff. Yeah, this thing's really running well, and so forth. So that's what CUDA gives you as a system. So I just wanted you guys to see that on the system. So I think I need to refresh this, and then I'll stop it. All right, so that is the system running on CUDA and how easy it is to get to the back end. So appreciate that. Like I said, that's going to be the longest example, I think, that I did there, because we reconfigured our application. So we're going to go back to the slide and talk a little bit about TensorRT. So let's go back to the slides if there's no outstanding questions here.
Actually, Steve, AB was asking what the final FPS on that run was, if you happen to have it.
Thank you. Thanks, AB, for asking that one. That was really silly on my part. So the FPS was 41 frames per second. Almost 42, 41.6. So big difference, right? On the whole system, and using the GPU and getting that thing cranking, and what the CPU could offload. So and then what will I do? So let's go ahead, and I'll make sure I show that. Thanks for asking that question, because that was important to see the difference. Let's go to TensorRT. So what is TensorRT? We talked a little bit about CUDA, having to know the nuances and so forth if you're working outside of alwaysAI's system on it. But what TensorRT does for you is it can take a model and it can parse up that model from the system and make one that's really optimized. So if you think about, if you're coding in C and you go ahead and run it through the compiler, at the back end of that compiler is an optimizer, and that's the same type of process. And it will after we see the demo, we'll talk about what it does. But TensorRT, basically, you're provided with an ONNX and a processor for ONNX-based models. So you can take your PyTorch model and save it into an ONNX format, and then you can run the ONNX parser against that, or from NVIDIA, or you can run a UFF parser against that. And that creates what we call a network, and the UFF is for TensorFlow models, right, that haven't been translated to ONNX. So what it does is creates a network or an intermediary piece. And then what you do is you do a builder system that will create it, and you can put different configuration flags into that builder to do things. And then you come out with an optimized TensorRT engine. And this is, like I said, this is highly optimized for that GPU and usage. And we'll talk about the different strategies that it uses to do this. But the idea is you may not see a huge bump in performance here on this one, because MobileNet's pretty fast. But if you have something like YOLO and so forth, it's pretty dramatic, even going from a CUDA-based system to a TensorRT-based system. But let's go ahead and it'll become more familiar as we go along. Let me see if I get this right, AB. So the question is, They're very intensive. So we do, and we have demoed internally FCN models running this. So that's a fully convolutional neural network. So it's a semantic segmentation one. And that's basically, so what AB is talking about, it's basically taking each pixel and assigning a class to it. So it's used a lot in industrial type applications. It used to be used a lot in earlier when they tried to run it in autonomous vehicles. It wasn't as successful there. Matter of fact, most car companies today are running object detectors of some sort or another in that. But he's right, it's a very intensive process, and you really see the kick in when you're running TensorRT on something like that. So anyway, just wanted to add on that. Good point from AB. Okay, so let's go ahead and let's start to do some TensorRT stuff. Now, in the repo underneath the models, I provided 2 TensorRT. One of the things we're doing right now is writing into our CLI, and we haven't released it yet. I'm not sure when the release date is going to be, so that we can take your model and translate it into a TensorRT model. That's not true today. So we do, if you're a customer and everything, we'd offer a service to do that. But because I want you guys to be able to execute and see the differences on your own within the Jetpack, or within the GitHub for this Hacky Hour on the Jetpack, I've included 2 TensorRT models, and you can load those up into your private catalog, because in alwaysAI we provide and I have all the parameters in the Git on what you need to do there. We provide a open source one, and then we provide a private one where you can load up and try and run your own models. And this is almost always used with people that use our model training. They load up the model and then they execute it. So anyway, those are there, so fear not. So what I want to do is get those models and add them to the project. So now this is where the fun of the dashboard comes in. So I have my dashboard. And so what I want to do is go into my models. And so this is a repo of my private models and so forth. And so what I have here is my model. And what I'm going to do is choose this model, one that runs on the GPU.
Steve, you weren't sharing your screen.
I'm not sharing my screen. I'm on my own. Okay. So let me go ahead and share the screen. You haven't much, so let me go back and redo what I did, because you should always share your screen. So let's go back and let's go back, and I'm going to go to my dashboard, which I will in. So with underneath dashboards, how you get to your private model set is you go into your dashboard and you do your models. You can see I have lots of them, but you go down to the bottom and there's your upload model. I've already uploaded these models because it's not interesting during a Hacky Hour to watch my model upload. So what I'm going to use is out of my private model set and my TensorRT optimized MobileNet V1. So I'm coming in and it's going to be the same process. I'm going to copy. I'm going to not do that. I'm going to go ahead and copy and then add this, sorry about that, add this to my project. And you can see, there you go for AB, wasn't line 41 on that. Let's go ahead and then highlight that, and I'm going to paste. So now my project's going to add this GPU model, which is a TensorRT model. And so now you can see I have my 2 models that I have. But what you'll see different now is instead of alwaysAI, it's going to say Steve Griset or my username on alwaysAI and the model. So now it's going to reference my private catalog. Okay, so we now have that. This time I need to make my change now to copy this. Hopefully I'm in the right place. Go ahead and downsize this. Yep. So I'm going to go ahead and copy this and then add this to my application code, right? So we get the right model. So that's step 1. I want to do that. So now I have, as you can see, it's always getting in my way, but you can see that I have the new model in there for my repo. And then again, what I want to do, and I could look at it within the constants as we've done before, I want to change this engine to look at TensorRT as my backbone. So what I do is I put in Tensor and RT. And so now that engine, and like I said, if you looked in the constants, it would be there. Now I'm going to be able to inference my model in TensorRT. So let's go back and I'm going to do this one. And so you can see I've added my model. If I wasn't sure, I could do that show command. So all I have to do now is to get this installed into the runtime container. And it's getting all the dependencies. So it's good. Hopefully you guys haven't all fallen asleep. I don't want to be a cure for insomnia here, but we're getting there. All right, so now we're loading up into the GPU through the TensorRT system. And again, everything looks the same as far as your application is concerned. When we go over here, let's see how it's performing. And you can see it's not dramatic. We've dropped down 4 milliseconds here on the system. I think it was going around 16 before, somewhere around that. It's dropping around 12 to 10. Same thing, just to show you this is live. Here I am on the system. So we'll have to go back. Go back here. Looks like this is freezing up on me. So so there you can see, looks very similar in performance on that. So it's tapping the GPU. It's like I said, a YOLO, you'd see a dramatic difference. This one, again, was fairly optimized for edge devices, so you don't see it too dramatic of a difference on this. So let's go ahead and do this right now, and we'll go ahead and yeah, I keep wanting to open the same one. So let's go on and we'll go ahead and we'll stop this. And we'll go ahead and check to see what, as it comes out. So your FPS was around 53 in this case. So it wasn't as fast for some reason on the loading of the GPU and so forth. But again, the inferencing time was a little bit faster, but FPS, and that could have to do with loading but from CPU to GPU wasn't as efficient this time for some reason on the compiler. But so still pretty good performance on that one. So and again, what you would see in a YOLO, you'd see dramatic differences. You probably see on CUDA somewhere 50, 60 milliseconds, and then you would see down in the 20s. On the inferencing time. So that's when you start to see the real differences. But anyway, that's TensorRT, how to get to TensorRT, still pretty high on the FPS system. So Lizzie, let's go to the slides again. So I have to stop sharing. Any questions thus far that we need? Nope, looks like we're okay. So how does TensorRT do all this stuff? So what it's really doing is, so what I should be saying is, let's step back to one of the differences between the models and so forth, just on memory size. So one of the things that it can reduce your precision. So the CUDA was running at floating point 32. When compiling what's normal as kind of your default for TensorRT models to run at floating point 16. So on on that piece. And so what it's done is it's reduced that precision, which means the size of the model and so forth is about half the size of what it was when you loaded it into CUDA. You can actually, because it has something called Tensor Cores as part of it in the Xavier lines, NX or AGX, you can actually get down to int8. But as you look at that other slide, you saw this little thing called calibration. You're going to have to run a calibrator and everything else like that to get the 8, to make sure the int8 isn't giving you poor results. The other nice thing that happens is what they call really the fusions of the layers or the tensors in the system. So what it will do is take stats on your model, try to run it as it's compiling TensorRT. As the builder is working, and what it will do is take a look at those stats and find out how do I combine some of the layers of the models or even remove it, and it does that. It's also really good at tuning what they call kernels, and kernels, if you think about cores, the kernels are the execution on the GPU of that core. And so it knows how to actually really optimize those is something it does. And then the other thing is, and you'll find this in CUDA and everything, how do I get the system to work asynchronously on a problem? And those are called streams and streams. That's just what their unit's called. It's a unit of work that's going on from the CPU to the GPU. So they always have syncs and so forth, and it allows you to work asynchronously and then sync back. TensorRT takes care of that for you automatically. So those are the strategies it uses to speed up, and it's automatically done by the compiler or the builder of the system. All right, let's go to our next slide. So in the Xavier line, we have they have something called the DLA or Deep Learning Accelerator. So what NVIDIA has decided to do on these higher end processors is add some more circuitry that can actually execute layers of a model in it, much like the Myriad system. And again, you can tell the builder that you want to use the DLA. So there's 2 of these DLAs in the system, and basically they have they have a memory bridge, which can actually transfer memory a little bit faster than actually loading up to the GPU. And then the other piece that I really wanted to mention and highlight here on the DLAs is that they're an open source project. So as you're developing your model, let's say you're up in PyTorch and doing that, you can see what layers will be executed. So you can actually create a pretty good system. And we talked about fully convolutional networks that tend to be older semantic segmentation network. A lot of that system can be executed on these DLAs. So why did NVIDIA do this? Well, let's say you have a robotics project and you're going to do mapping to it. So if you're using something like a mapper, using a SLAM system and so forth, you may want the GPU to do that, and then the machine learning system to be executing, the machine learning model to be executing on DLAs to free up your GPU processing speed and so forth. The other thing is that we've seen with some of our customers is they want to use the DLAs and they want to load. So you have 2 DLAs, 0 and 1. And so they may load one model onto 0 and one model onto 1. And again, it allows them to free up the GPU a little bit to do other types of analytics processing they want to do on the system and so forth. So the DLA is really neat, only available in the Xavier line today. And again, it's part of the builder process. We'll be glad to do some DLA for you. And then hopefully we'll get it into CLA or CLI system as we're moving forward on this. But in the private model catalog, again, in my private model catalog, if we go back to the I don't know why I did that. If I go back to models here and we take a look, this is my private. I have one that's targeted for DLA 0.
Hey, Steve, you aren't
Yeah.
sharing your screen.
Okay, how much did we miss? Probably not much. So let me go ahead and go back. I'm going to reset my system as we go forward. All right. No, I'm not resetting my system. Okay, hold it, and then let me go ahead and share my screen. All right, am I back to the world?
You're back.
All right. So again, within my private collection, I have one that's been done by the builder that's targeting DLA 0 on the system. So let me go ahead, and again, it's just we're giving you instructions on how to upload this and so forth. I could have made it DLA 1 if I wanted to also, but let me go ahead and just add this model to the project. You're probably really tired of seeing me pop up the wrong screen and do this, but anyway, here we go. So now we've added this third model to the project. We have to go ahead and add it to our code. And my code is where? Sorry, I have too many screens up right now. All right, so let's go ahead and let me go ahead and move this first before I paste. Go ahead and add this in. So now we're targeting it, still a TensorRT system on the DLA. So anyway, we have the system set up. We just need to run the install. And I'm going to do that. But first of all, one of the frustrations I've had with running this as a developer is actually executing on the system. And this led me to, of course, over to the NVIDIA blogs and everything else like that on it. Because JTOP really doesn't give you enough information about is a DLA active or not active. And what I found out is the device is keeping a lot of stats on its own. And so what I did was write a bash script for you, a bash script that's up underneath the tools section of the GitHub. And what that does is it monitors the GPU, and I'm using a standard Linux watch that runs every 100 milliseconds. And so if I start this, and again, the command's in there, what you can see is I'm going through and I'm watching the stats and checking the system as it goes. And what it tells you is, the DLAs are enabled on the system. If I ran this on a Nano, it'd say you ain't there. Right, and it's not enabled, and the controls auto, but we see right now there's no usage and the device is suspended. So I just want to do that. That's what I found to monitor. It also, as you look at it, at that script and everything, then into the directory, you'll see that there's other stats on that board, and you may want to create a similar batch script that's monitoring those stats. So it's kind of a neat experience to go into. I would say take a look at my bash script and then go into the directory that it's monitoring and take a look at all the stats that are in there. It's kind of fun, and you can use a similar type approach to getting some monitoring out of the board in real time using that scripting. So, but it's there for you. So let's go ahead and let's go back to this one and let's run our install command. Yes.
Okay, ask a quick question.
Yeah.
AB is asking if DLA runs over TensorRT.
Yes. So you use TensorRT to get to it. You're just stating it's going to ask you device type as one of the commands when you're building the system. And so the TensorRT builder is used to do that. And it's a TensorRT package, but it targets, instead of the GPU, the DLA.
Gotcha. I think that answers this question.
Yeah, the last thing I want to do is there's two ways to approach the DLA. Try to execute on all of it. Now, what's the problem with that? If you have a model, if your model has a layer that cannot be executed by it, it will core fault, right? It's not elegant. And so, but with that said, it has another flag you can set that say, if I can't execute that layer, drive it back to the GPU. And you'll find, as you look at the things, most models have to have fallback. And that's how I did this one. There's certain layers of the mobile net that will not execute on the DLA, right? So it will fall back to the GPU. So I just want to tell you, those are some of the nuances as you're working with it. But it is a TensorRT artifact, but it's just targeting a different device.
He's asking, how did you do that?
Yeah.
Or does it happen automatically? It's a flag you say you pass in?
Yeah, it's a builder flag. So on the configuration coming in, there's a builder configuration flag that you set in your script to build the engine on that. So
great. Thanks, Steve.
So that's just it. It's part of, again, a lot of documentations. We're trying to make that easy through the CLI and so forth and make that available to community. But like I said, right now, if you have a model that comes out of our training and you want to convert, just go on Discord and we'll take care of it for you. We have the scripts and everything else like that. But like I said, we're going to make it easy for you in the future. So we'll go ahead and load up. And again, just to do the testing of this and so forth, all that stuff's in the GitHub to get you started. It'll probably become a joke around the office. People will see me, hey, Steve, did we mention it's in the GitHub? I don't know. Anyway, let me go ahead. Said it so many times. Let's see. Let's go ahead and start and watch this go. We'll see you. All right, so we're started. Let's go over to our good old system. You're probably really tired of looking at my office, but anyway, there it starts going. The DLA is being utilized. How do we know that, Steve? Well, let's go over to this little guy right here. So you can see right here, it's not that neat. It's showing you the usage as it comes through. So at least I know it's up and running. JTOP won't give you that information, unfortunately, on it. So you can't really see what's going on with the system through JTOP. So there you go on that. So now you've run on their DLI. You can see it's active and in usage. This one's still suspended. I could easily put a model over on the DLA one and so forth. So as always, see what's going on from an FPS perspective. Now, the one thing I will say is making these models is quite an art. I've spent some time. I'm pretty good at YOLO. I'm pretty good at FCNs. I'm still learning how to load the DLL on MobileNet. So what you're going to see is a lot of ugly messages as I quit. And that is because of my skill set. So you see all the internal errors. It's okay. It doesn't really do anything. So this one was running probably our slowest, but probably less demanding on the G. Well, it wasn't our slowest by any standards, but that was obviously the CPU running. But it ran it at 45 frames per second. And like I said, this is all my noise, and this is because I closed it badly. I still have to figure out some nuances to the MobileNet architecture on that. Well, let's see. Is there any more questions out there on this? I'm going to leave it, or are we ready to? I think everyone's probably ready to do the contest. I think so. I appreciate you guys hanging in. I know it's not as much fun as Matt's, where you get to dance in front of the system and so forth, but this is this is how you're going to build an industrial strength system is through these different NVIDIA devices and so forth. We also are going to be doing some more accelerators in the future, so watch for it, and I'm sure some more giveaway of those future accelerators that are really designed around the x86 class to run a little bit with less wattage. You could see my performance at 20 watts. You'll start to see something that can equally perform with one partner that we're working on in the future. So anyway, I just wanted to tell that. So we got some exciting things coming up. So stay tuned and so forth. All right, Lizzie, I'll shut up. It's all yours.
Great presentation, Steve. Thank you very
Thank you.
much. All right, thank you everyone for sticking around to the very end and participating in today's Hacky Hour. Now for the moment you've all been waiting for, the person who answers this question accurately and the fastest in the chat will win a free NVIDIA Jetson Nano. The question is, what version of edgeIQ supports Jetson JetPack 4.6? And it looks like AB is the winner. Congratulations, AB. We'll reach out to you after Hacky Hour. And thank you everyone for participating. If you have any further questions about the presentation, you can email us at contact@alwaysai.co. And if you're interested in seeing our product in action, our team loves to do demos. You can schedule a demo by visiting alwaysai.co/schedule-demo. And if you'd like to watch this Hacky Hour again at a later time, it will be available on our blog. Once again, thank you everyone for joining us today. And thank you, Steve, for presenting. And we hope to see you at our future Hacky Hours.